Hi everyone. So in this video, we will be outlining main ideas, objectives of Lab 2, where we are identifying densities, or we're calculating densities, determining densities. We're going to learn how to use different instruments and how different instruments may affect the density measurement that you obtain. And we're also going to learn how to determine standard deviation of measurements. So just an introduction, a summary of density as always, or introductions always summarize, concepts. So for us, or for here, it's density. We know density is mass over volume. So just a lot of pertinent information, such as the units that typically show up for the different states, and then just some information on why density is important and why it's used in chemistry. So the instruments we're gonna, quote unquote use are these right here. These, you may have seen them before. Hopefully you saw them when you completed Lab 1 and you studied the common lab equipment. But all of these three right here are actually used for volume measurements. They're just different instruments or different glassware. And they each have their own purpose, right? Volumetric flasks, they give a very, very precise certain amount. So for example, this right here happens to be a 200 ml volumetric flask. So the very precise volume that it gives is 200 ml. It's not going to give you a precise value of 100 ml or a different, volume. A burette, you use it because you can control how much volume is coming out of it. So you can be very precise about how much volume you're adding, let's say, to something. And then graduated cylinders, those are kind of like just typical volume. It's something to measure volume with. So you measure out however much you need, if that's what you're doing. But these all measure volume. But like I said, they can affect how density overall, the measurement of it. So there's two parts to this lab, I would say. In the first part, you are actually completing a virtual simulation, and you are identifying the densities of these two liquids, but you don't know which liquid is which. But you do know that one of them, or two, they both have different densities. And I'll let you read through this, but that's the point of the lab, is that you are measuring their densities to determine which one is which. So what you're going to do, once you get to the procedure portion, you're going to open up that procedure, and you see that the virtual lab has to do with density. So, thumbs up, you're at the right virtual lab. So this is on a website called Chem Collective. So anytime you hear me talk about Chem Collective, this is the format that you'll see for the virtual lab. So we have a stockroom and we have a workbench. So you can go ahead and play around. You can bring things over from the stockroom, bring things over the glassware, whatever you want to do, just to get the hang of using everything. And then you can also get the hang of removing things. You can remove liquid. You can remove the entire thing in general, and clear out the entire workbench. So just get the hang of using the virtual lab. After that, you can go ahead and actually, understand what you need to complete. So I'm going back to the lab, scrolling all the way down. So you need to gather a few things. You need to gather compound A1, compound A2. If you're on the virtual lab, then you probably see these things. And those are two of the things that I actually brought over to the workbench. 6 volumetric flasks and a scale. Now, what is the main idea of what you're doing? I'm not going to sit here and read out the procedure step by step to you. That's so boring. It's way more fun if you try it on your own. So instead, what I'm going to do is tell you the main idea of what we're collecting, the data that we're collecting. So part 4 is your data collection portion. And in this part is where you actually either enter your values or you write them down if you printed it. So first thing you notice, we're collecting mass of the empty volumetric flask. So you can record this first, and then you add in your compound. Now, remember I said for volumetric flasks, they have a very certain amount that you're adding a volume to it. So notice that I told you to collect or to gather 100 ml volumetric flasks. So what you're going to do is you're going to add the liquid to the line, which indicates 100 ml. So it's not a trick question whenever I ask you what is the volume of the compound in the flask. It's straightforward. It's very straightforward. And then you are also measuring the mass of the volumetric flask and the compound. So you're going to record that here. And you're going to do this 3 times for each compound, hence the 6 volumetric flasks. And then what you're going to do is find the mass of each compound by subtracting the empty from the mass of the flask and the compound, right? So it gives you the mass of the compound by itself. And then from there, so now that you have the masses of the compound, right, we don't care about the mass of the flask. That's not what's of interest to us. We want to find the density of A1 and A2. So you have the masses and you have the volumes. So I'll let you guess what you do from there, but you need to calculate the densities of A1 and A2, show all your calculations, and then based off of the introduction where it tells you, the little story, the situation of what happened, you will tell me which one is the neurotoxin, compound A1 or compound A2, and which one's the preservative. So that's part 1 of the lab, I would say. And then you have to make a table. So just make a table of the results. And so here, it can be like you calculating things out, taking your masses, dividing by your volumes. And then here, just make a nice table summarizing those densities. That's all that I want there. And now we're at the, I would say second portion, which is your applied exercises. Here we're dealing with Coke and Diet Coke, and we are looking at the densities. Now, Coke and Diet Coke are mostly water, right? So obviously you're going to think the density is close to 1 for both of them, but they may be different, right? Coke has sugar or high fructose corn syrup. That's a whole nother thing, whole nother story. But Coke has one thing in it, sugar, and then Diet Coke has artificial sweetener. So they have different things in them. So we know that the densities may be affected, a little bit by that. So we have both of these liquids, Coke and Diet Coke, measured with different glassware, with a graduated cylinder, with a burette, and then also with the volumetric flasks. Notice that we have mass and volume for both Coke and Diet Coke, and then we have masses for both of these, and then initial and final. So for burettes, what you need to do is take your final, subtract away your initial. That gives you your volume, right? So that's how you'll get those volumes. Sorry about that. And then for volumetric flask, it's already given right away. But essentially what you're doing is you are calculating a lot of densities. I'm not going to have you write out every single density calculation because I know it's a lot. What you're going to do is show me some sample calculations. So show me the calculations for determining the graduated cylinder versus the burette, and so on. So that's what you're doing here. You're determining the densities of both liquids using those 3 different instruments. And then you are calculating the standard deviations. So standard deviations, they are important. They give you how much variation there was whenever you completed whatever it is that you're doing, mathematically, whatever sample of data that you collected. So it's going to show you which one had the most variability, which instrument has the most variability when you're measuring. So it's going to show you which one is probably the best one to measure volume with, right? Between the graduated cylinder, the burette, and the volumetric flask. So you're going to follow this equation. I have like an example kind of outlined here right under it. If you need, sorry about that, please visit, YouTube standard deviation calculations. And any simple calculation about standard deviations will work. I probably will just add a standard deviation calculation video on the optional video. So you may see that pop up. I'm going to have to do that after I put this video. And then you will answer the following questions in complete sentences. So notice I caps complete because I just really want you to, like I said, practice that scientific writing. So as always, if you have any questions, please let me know and I'll be here to help.